Our next speaker is Stephen Hennessy. He'll be discussing what upgrade improvements can be made to existing office buildings. Stephen Hennessy has again been involved in this space for a very long time. He has 30 years of experience as an engineer, and he's an internationally recognised authority in energy and sustainability issues. His work has included high-profile projects including the new Parliament House in Canberra, High Court of Australia, the Sydney Opera House and the National Gallery, and Aurora Place in Macquarie Street and 321 Exhibition Street. So kindly welcome Steve Hennessy.
When Matt said international expert, he means I've been to New Zealand. Between 80 and 90% of all of the base building energy is consumed by the heating, ventilating and air conditioning equipment. In fact, if you look for single items of equipment, chillers on their own are very energy hungry, and a single chiller can account for up to 20% of the energy used in a building, and combined, according to this graph, 32%. But look, knowing that heating, ventilating and air conditioning is the main culprit, well, I think will help you understand why I'm focusing on that title. What can you do? This section should really take up the whole of the afternoon. Obviously we haven't got time for that, so I'm just going to focus on a few relatively simple things. And I'm going to focus on the operations side, because usually there's some easy wins there. In engineering terms, you'll often hear the term low-hanging fruit. Well, some of these are probably best described as watermelons. And the reason I'm focusing more on the operations side is it will become clear when Alex speaks about some of the experiences from low energy high-rise. So if we look at energy savings, energy use is to some extent, or to a major extent, designed into our buildings. So basically good design saves the most energy. Energy conservation works hand in hand with good design. And turning to technology is something that you would do after you've exhausted those first two. And when we look at high-performing buildings, we find that they have good thermal performance, and that would include proper orientation and right selection of materials. That the heating, ventilating and air conditioning will have been well designed, and very importantly, that the heating, ventilating and air conditioning will be properly maintained and properly operated. Good design aims for low energy use. Solar gains are controlled through shading and through appropriate glazing. Proper insulation is present and thermal mass is utilised where practical. Proper controls are carefully specified. Infrastructure is better utilised through load management. Power factor correction can certainly help with keeping demand costs low. Fans and pumps should be properly sized, and variable speed drives should be used to provide necessary fine-tuning. Now I'm going to let you into a secret about engineers. Not only are they shallow, but they over-design things, they oversize things. So when an engineer is starting off with a clean piece of paper and he designs a cooling system, or he designs a heating system, and he selects the pump, he's going to add 10% to the duty of that pump, just in case. Now that's, okay, belt and braces. When that goes to the company that's responsible for installing it, they assume some of that design responsibility. So what do? They think, I better add 10%. So they add 10%. So unfortunately, it's just what happens in our industry. Things tend to be oversized. So what do we do when we oversize? Well, if we oversize the pump, one of the things we do is we bring the pump down to its right duty, and we put a valve on it, and then we shut the valve. Now, if you were driving a car, do you think it's appropriate that you would drive the car with your foot flat on the accelerator and control the speed through the brake? But that's what we do. Variable speed drives at least allow you to take your foot off the brake and adjust the speed. And then finally, other technologies such as combined heat and power often considered in good design. It's one thing to have a good starting point, it's another to achieve good results. The way that we operate and manage buildings plays a huge role in all of this. So take, for instance, temperature set points. It's quite common that the set points are arbitrary. We pick a set point for our building. But the reality is that there's a lot more that goes into human comfort than just the temperature. This is taken from an ASHRAE guide. ASHRAE is the American Society for Heating, Refrigeration and Air Conditioning Engineering. Being appropriately dressed for the season. It sounds blimmin' obvious, but we ought to think about these things, and there's certainly one major property owner out there that is pushing the boundaries of these set points. So if you can move the upper set point in summer from, say, 24 to 24 and a half, it might not sound like a lot, but it can make a huge difference to your energy consumption. Having bait on your hook significantly increases your chances of catching fish. Now, that's one of the bleeding obvious statements that I make when I go fishing with my boy, which is probably why he hates me. But another one of my bleeding obvious statements is that you will never save more energy than you will by turning something off. And you'd think it is bleeding obvious, but it isn't that obvious. In buildings, we tend to start our equipment at a particular time, and that's regardless of what's happening outside. So it's not uncommon for the air conditioning to come on up to 2 hours, sometimes 3 hours, before the building is classed as occupied, so that we can get the building to be comfortable by the time the people come in. And of course, it's not uncommon that the equipment gets turned off after the people have left. Now, in most modern control systems these days, there is a feature called optimum start and very often optimum stop. And this just adds a bit of common sense to the whole process. Basically, these systems will look at the outside air temperature and it will determine the best time to start. So, for instance, on a very, very hot day, and it's been hot overnight, it is true that we may have to start the plant quite early. In the interim seasons, and might not be the case. So if we need the building up to temperature by 9 o'clock, an optimum start system may determine on some days that it needs only start the building at 8:30 or 8:45 to get to those temperatures. An optimum stop's another good example. A lot of people leave the building before the air conditioning has to go off. I'm not suggesting you shut the air conditioning down, you'd leave the ventilation running, but you might not need to run the chillers, you might not need to run the boilers. There's a building in Parramatta where they found that they could shut down the chillers and the boilers at least 45 minutes before the building was meant to shut down. And again, a huge energy saving to be had out of that. Night purge can often make sense. If it's a cool night in the middle of summer, we certainly have cooler evenings. Perhaps we can use that air and bring it into the building in the wee small hours and just cool the building down a bit, get rid of some of the heat. You've got to be careful because you don't want to be putting more energy into the fans to move the air around than the energy you save, but night purge can be a viable strategy. This is a nice one. I often walk into a building manager's office and start playing with the controls. I told you I was shallow. And I usually find set points that are all over the place. Why do we have set points all over the place? Well, usually it's a lot easier to fiddle about with the controls than it is to actually resolve the real problems. Minimising the use of reheating. If you've got, for instance, most buildings these days, most commercial buildings will have variable air volume systems. Two ways of if we need cooling in this room, two main ways that we would deal with it. One is we bring in a fixed amount of air and we change the temperature of that air. The other is that we bring air of a cold temperature and we just vary the amount of air that comes into the room. So if we need more cooling, we bring in more air. The trouble is that a lot of the systems serve more than one space. So if I'm serving this space and the space next door, and suddenly this space gets occupied, I'm going to have to do a lot of cooling in here to deal with the heat from all of you, but next door might not need it. And it is possible, if it's fed from the same system, I may have to reheat the air going into the other side. If you rethink your maximum and minimum settings, you may be able to minimise the amount of reheating. But if you really do have major changes, if you've got a lot of reheating going on all of the time, you might want to actually think about redesigning your systems and the way it serves it. Airflows and retro commissioning. When we hand over a building, it's nice to think that it's been set up properly. It more likely isn't, but that's another story. Let's just dream for a moment. However, things change over time. It makes good sense to revisit the original design assumptions periodically and see whether what was originally assumed still applies. And in an extreme example, I was involved with a building where the space was air-conditioned 24 hours a day, 7 days a week. There was particular work going on in this space, it was always occupied. When I went to the site, that particular space had changed its occupancy pattern about 3 years earlier. And they were only occupying it Monday to Friday, normal business times, but the plant was still running 24 hours a day, 7 days a week. Now, I'm not saying that's the typical of office buildings, but those kind of things can happen. And getting the air balance right is absolutely critical. In my experience, air balance is one of the biggest causes of complaint in offices, and it's one of the main reasons why the building manager changes those set points, because he can't think through what the actual problem is. The easy solution is if I change the set point, we'll bring on extra heating and that person won't be cold or quite so hot. I did mention that chillers are the biggest single energy consumers. Modern chillers are certainly much more efficient than they were even 5 years ago. There's been a quantum leap in efficiency. But if you are upgrading, first off, make sure you get the most efficient chillers that you can. The cost difference between ordinary and efficient is quite small when you think that piece of kit is going to be there for the next 25 years. But also you need to take a holistic view. Modern chillers achieve phenomenal efficiency by having or trying to drive the condenser water temperature down. So you can't just look at it and go, well, I'll refit my old chiller with the same thing and not look at the controls and the condenser water systems and the like. And it also, in the old days, a chiller was at its most efficient when it was running flat out. Now the chiller's efficiency tends to be better at part load, so there may be opportunities, and you have to think this through. It's system related, but in some cases it may actually be better to run 2 chillers at part load than 1 chiller at full load. But look, please remember, you do need to be vigilant. Don't let the controls be used to cover up problems. Don't let the contractors use the controls to cover up or solve other problems. You do need to keep an eye out for energy savings at all time, and it's not set and forget. You can't just say, well, I've done all of these things. You've got to be eternally vigilant. I'm going to tell you another secret about engineers. Most engineers love the new. The existing is a problem, but they love the new. They love great design. In a previous existence, I worked with some great designers, and when it comes to engineering, this is sexy. Doing interesting things with shape and form, that is sexy. Winning big international awards, that is sexy. Can I tell you that maintenance is not sexy? The people who work in maintenance aren't sexy. And the kind of work they do isn't sexy. Can I also tell you though, when things go wrong, the results aren't sexy either. Now, look, I've got a fair bit of experience in maintenance management, so when I go into a new project, what I like to do is gather the information, the energy information, ideally for the last 3 years. We'll take that energy profile, we'll average it, and we'll set up a base year. Then we put in place proper maintenance and we compare the energy use going forward with previous energy use. And in my experience, there are significant savings to be had. Generally around 20% of the house power just by doing maintenance properly. So there's obviously a big difference between ordinary maintenance and proper maintenance. What can you do? Well, you could pray, but I favour a more proactive approach. And I'm a great believer in you need to specify what you want. You need to have proper maintenance specifications in place. Don't leave it up to the contractor. You need to work this out yourself. You can work it out with the contractor, but you need to be actively involved. You need a program of works that says what's going to be done and when. So for instance, if you are having a major chiller service, you want to have that chiller service done prior to the onset of the cooling season for its major service, because the chiller guys are under a lot of pressure from the property owners who know to do all of that work. They're actually going to want to do the major chiller service when they've got guys available, which is outside of the cooling seasons. So make sure that you specify what's got to be done and when. You need to have good instructions for the technician. Maintenance specifications that say do it as per the manufacturer's instructions are not worth the paper they are written on, unfortunately. The manufacturer does not necessarily know how their equipment is going to be used in your building. No two buildings are the same. Why would maintenance specifications be exactly the same? If we aim for generic, we're going to end up with poor performance. Finally, you should have a medium on which to report results. So get the maintenance contractor involved, get him reporting back. You can't be around your building all of the time. The maintenance contractor is working round through your building. If he sees things, encourage him to report it back. Have some system in place where they're rewarded for that. And finally, proper supervision is absolutely essential. It's not a set and forget exercise. Think about it from a maintenance contractor's point of view. He sold you a contract. You're paying him a certain amount of money each month to do that contract. They're diligent, they want to do the right thing. Phone rings, there's a problem on another site, can they attend a call out? That call out's a paid call out. If they do that call out, whilst they've got time booked to your job, they're actually getting paid twice effectively for that. There's a huge pressure on contract, and even the best contractors feel this pressure. So you do need to supervise it, don't leave it as set and forget. We had a look at operations opportunities, think about set points, night purge, retro commissioning, and of course air balance. And then finally, I put in a few choice words about proper maintenance. Well, that's pretty well all from me. I did mention that in conjunction with Sustainable Business Australia, we'd developed a one-day training module, and it covers basic energy-saving opportunities with heating, ventilating and air conditioning equipment. If you are interested in that, please see Matt Fisher at the end, and he might be able to have a word with OEH and find if that can be put on again. Thanks for taking the time to listen.